Yeah, so we are discussing about the objectives of size reduction. So first objective of size reduction, what we said, is determining the average particle size. So particle size distribution is very, very important. In fact, this is also important for finding out the efficiency of size reduction. So average particle size and effectiveness of the size reduction equipment analyzing also done by this size separation technique. Next very important objective is to get the fine state particles that is under the 10 micron size so that they can get absorbed from the GI tract rapidly. So there are certain drugs which are needed to be extremely fine. So GI tract will absorb kavalite. Example is Bisofelvin is an antifungal drug, like aspirin, analgesic and antipyretic drugs. Therefore, centrifugal classifiers, one of the fine size separator techniques are used to do this kind of experiment. So size separation is also essential for evaluation of efficiency of different equipments used in size reduction. Already we discussed. So these three are objectives. Okay, determining average particle size. రెండోది like to obtain like extremely fine particles like less than 10 microns to get very good GI absorption, like in the case of Bisofelvin and aspirin. And third important thing is to find out and to understand the efficiency of size reducing equipments. So these are the objectives. And then mechanisms of size reduction is చాలా ఇంపార్టెంట్ అండి, చాలా మందికి తెలియదు. There are three different mechanisms of size reductions: oscillations, vibrations, gyration. What's happening in oscillation? In this type of motion, the movement of sleeve takes place with the help of rotating shaft. So oscillate అయితూ ఉంటుంది. The sleeve placed on the frame are moved into and fro motion, to and fro motions like pendulum, corresponding to the plane of the sieve. So oscillation is one of the mechanism of size separation. Next is vibration. In this type of motion, the material is placed on the sieve, which is then subjected to high speed vibrations by employing either an electric or mechanical device. Then you have gyration. In this type, an eccentric flywheel is used for rotating the seal at a fixed axis in a circular motion. సింపుల్ గా చెప్పాలంటే పిండి పట్టేటప్పుడు కావచ్చు, అండ్ మెనీ ఇన్స్టాన్సెస్ జనరల్లీ సైజ్ సపరేట్ చేసేటప్పుడు జల్లెడ తీసుకొని ఎలా చేస్తామండి? ఫస్ట్ విల్ సింప్లీ మూవ్ విత్ ద హ్యాండ్, దట్ ఈస్ ఆసిలేషన్. Then you will try to tap it with your hand, that is vibration, right? Then gyration means it will be different type of particles. If it is not rava, it's not powder. If it is like bm goduma అనుకున్నప్పుడు we will gyrate it. I hope you can understand uh, the three different types. So if possible, I will try to show you. If you see my screen, yeah. So imagine if this is a seed. So generally మనం ఇలా మూవ్ చేస్తామండి జల్లెడ పట్టేటప్పుడు. This is oscillation type. Right? Vibration is tap చేస్తాం మనం. We tap it. Right? That is vibration. And gyration అప్పుడు బియ్యం పట్టేటప్పుడు ఎట్లా చేస్తాం? ఇట్లా ఎగరేస్తాం. This is gyration. I hope you understood. So it's very awkward to show this on with the mobile phone, but what can I do? I want to make you understand these three mechanisms of the size separation: oscillation, vibrations, and gyration. These three are the mechanisms of size separation. So you should remember it and please note it down: oscillation, vibration, and gyration. Because when we start discussing about the equipment, we will come across these terminologies. Please note it down: oscillation, gyration, and vibration. Three objectives of size separation, three mechanisms of size separation. In objectives of size separation, I said there are three objectives. One is efficiency of size separation kosam, size reduction kosam we use. Other objective, what we said, other objective is determination of average particle size. And the third objective is to obtaining fine particles less than 10 microns is the objective of size reduction. And mechanisms, oscillation, vibration, and gyration. Done. Can we move forward?
Okay.
Yes? Yeah. Next, this is the important slide which you are seeing on my screen. Andy. Can you see the table on my screen? You can see coarse powder, moderately coarse powder, moderately fine powder, and very fine powder. Can you see these? Can you see this coarse powder? I'm highlighting it. Moderately coarse powder, moderately fine powder,
Moderate.
fine powder, and very fine powder. Right? So the important thing here is coarse powder ante enti. Sieve through which all particles must pass. 10 numbers sieve నుండి అవన్నీ పాస్ అయిపోవాలి. అక్కడ మెష్ అపరేటర్ సైజ్ హోల్ ఎంత సైజ్ ఎంత ఉండాలి 1700 మైక్రోమీటర్స్ అండ్ సైజ్ త్రూ విచ్ 40% particles pass should be 44 sieve number. Mesh aperture size of that sieve should be 355 micrometers. అంటే sieve number 10 నుండి పాస్ అవ్వాలి, sieve number 44 మీద ఆగిపోవాలి. So that's what he is trying to explain you. Example, see, ఇది sieve number 10 అనుకుందాము, ఇది sieve number 44 అనుకుందాం. This is sieve number 10. This is sieve number 44. You can see that on screen.
Okay.
So he is speaking something about this one. Aperture size. What is aperture size? In the sieve number 10, the aperture size ante itluntayi kada. Now I will try to highlight it. ఇది అపర్చర్ సైజ్ అనమాట. సో సీవ్ లో ఇవన్నీ ఉంటాయి కదండి జల్లెడలాగా. సో ఆ హోల్ సైజ్ ఎంత ఉంది అని అంటుంది. దిస్ ఇస్ అపర్చర్ సైజ్. నేను ఆ పింక్ హైలైట్ చేశాను కదా, దట్ ఈస్ అపర్చర్ సైజ్. దట్ సైజ్ షుడ్ బి 700 మైక్రోమీటర్స్. అది క్రాస్ అవ్వాలి, రైట్? వేర్ యాజ్ ఇన్ sieve number 44, that is 355 micrometers. So what you understood, if sieve number increases, the aperture size will decrease. Got it?
Okay.
Yeah, I'm highlighting this yellow one. This is the aperture size in sieve number 44. So sieve number 44 aperture size ఎంత ఉంది 355 micrometers. In sieve number 10 aperture size is 1700 micrometers. అంటే sieve number 10 దూరం దూరం ఉంటుంది, పెద్ద పెద్ద particles can pass through it. Whereas in sieve number 44 ఆ particles pass కాకుండా ఆగిపోతాయి. Right? So coarse particle ante garuga unde particles. They are not so fine like sodium chloride crystals laga untayi. So coarse particles should pass from sieve number 10 but shouldn't pass from sieve number 44, or at least 40% particles sieve number 44 nundi pass kaakudadu. Then it is coarse particles. Then moderately coarse, slight change chudandi. Here he is saying in moderately coarse 22 sieve number నుండి క్రాస్ అవ్వచ్చు, వేరాస్ 60 sieve number 40% particles క్రాస్ కాకూడదు. Moderately fine 44 sieve can cross, right? 85 sieve it shouldn't cross. Fine powders means they will cross 85 but they shouldn't cross 120 sieve. Very fine powder means they can cross 120 sieve but they cannot cross 350 sieve. Understood? సో ఏం గుర్తుపెట్టుకోవాలి అంటే ఇక్కడ సీవ్ నంబర్స్ గుర్తుపెట్టుకోవాలండి. సీవ్ నంబర్స్ ఆ ఏ పార్టికల్ ఎక్కడి నుండి క్రాస్ అవ్వగలుగుతుంది అన్నది ఇంపార్టెంట్. దట్ ఈస్ ఇంపార్టెంట్. కోరస్ పౌడర్, మోడరేట్లీ కోరస్ పౌడర్, మోడరేట్లీ ఫైన్, ఫైన్, వెరీ ఫైన్. టేబుల్లో ఇవ్వండి ఇంకోటి మైక్రో ఫైన్, సూపర్ ఫైన్. See, coarse powder lo what is the explanation given? Have a look. All the particles of this powder pass through the sieve number 10. చెప్పుకున్నాం మనం. That is nominal mesh size is 1700 micrometers. But more than 40% of powder 58 must pass to sieve number 44. అలానే కోరస్ 22 and 60 మధ్యలో రైట్ మోడరేట్ 44 నుండి పాస్ అవ్వాలి 60% పౌడర్ షుడెంట్ పాస్ ఫ్రమ్ 85 ఫైన్ పౌడర్ లో 85 to 120 వెరీ ఫైన్ 120 to 350 మైక్రో ఫైన్ మోర్ దెన్ 350 సూపర్ ఫైన్ this powder in which the number of particles is not less than 10 microns. The things to be remembered here is nominal mesh aperture size and particle sizes. 45 microns microfine low, superfine low 10 microns particle size. See, we started from 1700 micrometers, we ended at 10 micrometers. So superfine particles cannot cross 10 micrometers, less than 90%. So this classification at least you should remember. Porous powders, moderately porous powder, moderately fine, fine powder, superfine. Okay, can we move? Yes. No one in the class? Yeah. So next important thing, Andy, you can have a look at sieve sizes. Starting from sieve number 4 నుండి sieve number 350 దాకా ఉంది. Generally, we don't use all these sieves in pharmacy. We generally use, I'll show you if possible. Yeah. We use sieve number 10 very commonly. 12 వాడతాము 16 వాడతాము 22 వాడతామండి 44 వాడతాం మన ల్యాబ్స్ లో 60 వాడతాము 100 వాడతాం. These are the sieves generally used in our laboratories. So sieve number 10, approximate percentage of sieving area 41% ఉంటుంది. Nominal mesh aperture size 1.4 micrometers ఉంటుంది. 12 లో 10 లో 1.7 ఉంటుంది. అండ్ టాలరెన్స్ ఆఫ్ పార్టికల్స్ ఎన్ని మైక్రోమీటర్స్ పార్టికల్స్ టాలరేట్ చేస్తుంది 0.06 మైక్రాన్స్ 0.5 మైక్రాన్స్. అండ్ లాస్ట్ ద బెస్ట్ వన్ వాట్ వి యూజ్ ఇస్ sieve number 100. సో ఇక్కడ వచ్చేసి percentage sieving area is only 36%, and nominal mesh size will be 150 micrometers, and tolerance range is nearly 9.5 to 6.6 micrometers. So these are the general sieves, at least you should remember. Sieve number 10, 12, 16, 22, 44, 60 and 100. So Indulo, if I ask you which sieve is used to sieve coarse particles and which is used for fine particles, at least చెప్పండి. Sieve number 10 is for coarse particles. నెంబర్ చిన్నగా ఉంటే పెద్ద పార్టికల్స్ వస్తాయని అర్థం. Sieve number 100 is for fine particles. So please you should remember that. Okay. So
Okay.
sieve shaker, you can see the sieve shaker is a very common sight and very simple one. Many people remember this sieve shaker. We have set of sieves arranged, right? So standard sieves having different mesh numbers are commercially available as per the specification of IP and USP. On the top of each other is mechanical shaker. So this is the mechanical shaker, and in this different size the sieves are arranged. So when you add these particles to be size separated in this, it will be either using any mechanism of oscillation or vibration, and it will subject it to size reduction, size separation. So particles are being size reduced. So working the process of sieving method is as follows: the sieving covering entire particle range of the sample to be the best are being selected. So next, the sieves are being placed on upon another collecting pan in each way. చెప్పుకున్నాము. Smallest aperture is at the bottom. Smallest aperture size అంటే హైయెస్ట్ నెంబర్ ఉన్నది బాటమ్ లో ఉంటుంది. సో ఇక్కడ సీవ్ నెంబర్ 10 ఉంటే అండి ఇక్కడ సీవ్ నెంబర్ 100 ఉంటుంది. సో ఇలా ఫర్ ఎగ్జాంపుల్ మనం తీసుకుంటున్నాం 10, 12, then 16, then కిందది 18, then 22, then let's say 80, 60, 80, 100 అనుకుందాం. 80, 100. సో స్మాల్ ఎపర్చర్ సైజ్ ఉన్నది కింద ఉంటుంది, లార్జ్ ఎపర్చర్ సైజ్ ఉన్నది పైన ఉంటుంది. అది బేసిక్ arrangement that you should remember. Okay, so this is sieve shaker. So sieve shaker, we will arrange the different sizes sieves and we will subject it to the mechanical shaker. So working load, the sieve covering the entire particle size in the samples to be tested are selected. Sieves are placed. The sieves are shaken for 20 minutes and then each sieve is removed from the nest. So if any fine powder is retained on the sieve, it is gently removed with the brush. So simple mechanism, just arrangement ఎలా చేస్తున్నాం అనేది చూసుకుంటే సరిపోతుంది. About the sieve shaker uses, sieving method is used in dosage form development like tablets and capsules. Merits, it's an economical, easily reproducible. Coming to demerits and limitations, sieving the particles may accumulate to form aggregates due to the production of electrostatic charges. So one important demerit is development of electrostatic charges. Electrostatic charges develop అయితే solubility దెబ్బతినే chances ఉంటుంది. Second, presence of moisture in the powder is also one of the reasons for aggregation. So particles can aggregate and can form into lumps. ఆ lumps లాగా form అయితే sieving proper గా కాదు. Next, on sieving, attrition of the particles result in gradual reduction in the size. మనం అనుకున్న సైజ్ కంటే కూడా సైజ్ రిడక్షన్ పెరిగిపోవచ్చు బికాస్ ఆఫ్ attrition. This is one limitation. The duration of mechanism of taking sieve loading are the two factors which affect the desired product. Inter factors, shaking ఒకటి, duration is two, can also affect the particle size. So these are the limitations, the demerits of size separation. So size separation, we have seen different sieves. We have seen what are the classification, right? That is porous particles, moderately porous, right? Inka moderately fine, ultra fine, very very fine particles. So and which sieves are used there? Micro fine and super fine particles. Then we are seeing about different sieves. We have seen that in pharmacy we are going to use sieve number 10, 12, 16, 22, 30, 44, 60, 85, 100 దాకా మాక్సిమం వాడతామండి. మిగతావి వాడము అని చెప్పాను ఎక్కువగా. దెన్ వి డిస్కస్ అబౌట్ ద సీవ్ షేకర్. సీవ్ షేకర్ లో గుర్తుపెట్టుకోవాల్సింది ఒకటే, ఇది ఇట్స్ అన్ ఐపీ స్పెసిఫికేషన్, జనరల్లీ యూజ్డ్ డ్యూరింగ్ ద టాబ్లెటింగ్ అండ్ గ్రాన్యూల్స్ ని సపరేట్ చేయడానికి వాడతాము. జనరల్లీ వి విల్ అరేంజ్ ద డిఫరెంట్ సైజెస్ సీవ్స్ ఇన్ దిస్ నెస్ట్ అండ్ విల్ సబ్జెక్ట్ ఇట్ టు ద మెకానికల్ స్టిర్రర్. పెద్దగా మెకానిజం గుర్తుపెట్టుకోవడానికి ఏముండదు, చాలా simple. But there are a lot of demerits which we discussed, which can lead to accumulation of the particles, right? And some duration and what efficiency reduction is being affected. Attrition of the particles can take place. Moisture in the powder can lead to aggregation. Lanti simple demerits unnai. Now the very important part of today's class is cyclone separators. We discussed in last class. I hope you remember. Cyclone separators are generally used to separate air from dust, or I can say that the solid fine particles are separated from stream of air. Yeah, so these are the two I can say reasons why we are going to use the cyclone separators. Very simple, very easy equipment, and in this equipment we are having a conical bottom unna flask. So I'm drawing in front of you ila conical bottom unna flask untundi. Tangential entry, the mixture of air and the solid particles enter like this tangentially, and when it hits the opposite side of the wall, it creates a cyclonic effect. So ila cyclonic effect create avadam valla centrifugal force is generated, heavier particles are falling down and lighter particle, that is air, is separated from the top. That's it, what's happening in cyclone separator. Very simple equipment, very easy equipment, and generally this equipment is used as a part of other equipments where we are going to separate the solid particles from fluids. So you can see the principle. Cyclone separator is a type of sedimentation technique which works on the principle of centrifugal force. ఇందాకే చెప్పాను నేను. Principle here is centrifugal force rather than the gravitational force. Based on the fluid velocity, cyclone enables to separate all the particles. That is, porous particles can be removed. Why? How? Because of centrifugal force, they are falling down. Fine particles can be carried out with the air, top level flow. So ila cheyochu. So fine and porous particles can be separated, which are mixed in the air by using cyclone separator. Principle used in cyclone separator ఏంటండి? Centrifugal force. That you should remember. Working very simple. Suspension is introduced. Air suspension is introduced 25 to the tangential entry into the high speed చెప్పానని ఇలా enter అవుతుందని. Right? It provides rotatory movement inside the vessel. The fluid outlet located at the top of the vessel helps in removing the fluid. పైన నుండి fluid remove అవుతుంది and fine particles carried by the air will be removed. కింద నుండి coarse particles or heavy particles will be removed. That's about the working uses. It is used for separation of suspensions of solids in liquid with the preference of suspensions of solids in gas also. It's also used for separation of heavy porous particles and fine dust can be separated. Demerits, it operates cost in high, operating cost in high due to the pressure drop. It shows low efficiency of small particles. It cannot be used for sticky and greasy material. So these are the limitations for cyclone separator. So cyclone separator principle గుర్తుపెట్టుకోవాలి. What is the principle involved here? Centrifugal force. So that's the important thing you should remember. Second thing is you should remember that it is separating heavier particles from the lighter particles, coarse particles from fine particles. Third thing you should remember in cyclone separator is helping us to carry the lighter particles to the stream of air from the upwards of the cyclone and heavier particles from the bottom because of development of centrifugal force. Next
Force.
important is air separator and the equipment. Speaker, Mazhar, listening?
Yes, sir.
Okay. Bhaskar Gar is not connected. Press new link. Okay. Yes. So, next important thing and the air separators గురించి చెప్పుకోవాలి. Cyclone separator, air separator, almost same with slight variation. I can show you the slight variation. You can clearly see in the picture. So, rotation slow. Yeah. So you can clearly see in the picture. What can we see is, yeah, conical bottom is there, but you have two outlets. In cyclone separator, you have one outlet. In air separator, you have two outlets. And in cyclone separator, air is entering tangentially. But in air separator, air is not entering tangentially, or feed is not entering from tangential entry. So that's the basic thing. What can we see? In air separator, we can see that there are rotating disc and rotating blades which can generate centrifugal force, centrifugal air, and the feed is mixture of the heavier and lighter particle is coming from the top. And you have two outlets. One outlet is for the heavier particles, one outlet is for the lighter particles. See, ఏమైతుంది ఇక్కడ? You can see that lighter particles are carried with the air, fine particles, and they are touching to the walls of the container. So ఇలా ఈ అవుట్లెట్ నుండి బయటకు వచ్చేస్తాయి lighter particles. You can see like this. ఇలా వస్తుంది. I'll change the color. so that you can see. Like, whereas heavier particles, because of their weight, they can't be carried till the corners of the wall and it couldn't be collected. Heavier particles because their weight is high. Then see here construction air separator consists of a cylindrical vessel having a conical base, feed outlet on the top, and two outlets. One is for finer particles, one is for heavier particles. Two outlets for fine and heavy. Working చూడండి మీకు క్లియర్ గా అర్థమవుతుందండి ఇక్కడ. Working student, the motor driven disc blades rotates and produces an air current as shown by the arrows. Air current is produced. The powder is fed through the inlet and it falls onto the rotating disc. Fine powder is picked up by the air and touches to the walls of the container. So a fine powder is collected, right? And
Okay.
air is carried out. Here the air velocity is reduced. Thus the fine particles fall down and are collected on the outlets of fine. Heavier particles fall downwards and are collected by respective outlet. So heavier particles cannot be carried by the air కాబట్టి అవి డైరెక్ట్ కింద పడిపోతుంటాయి. ఇక్కడ heavier particles ఇందులో వచ్చేస్తుంది రెడ్ కలర్. Lighter particles I am showing you with the yellow color. Lighter particles corners నుండి వస్తుంది. ఇక్కడ నుండి lighter particles వస్తాయి ఇందులో. So this is the air separator. So principle involved here is also again centrifugal force created by the air. Combination of centrifugal force another is used. Current air combined with the centrifugal force is used as a principle. So principles and mechanisms are very 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 important. So manam sites air separation lo we have seen two equipments, cyclone separator, air separator.
Yes.
The difference between cyclone separator and air separator have two outlets. One is for fine particles, one is for heavy particles.
And heavy particles.
Yeah, whereas in cyclone separator you have only one outlet. In cyclone separator you don't have any fans and discs to generate the centrifugal force in the air, whereas in air separator you have disc and rotating blades to generate the centrifugal force and carry the lighter particles. So that is the basic difference between these two. Now the very 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 important part of the size separation is back filter. This will conclude our class after this back filters. పేర్లోనే ఉందండి క్లియర్ గా there is a back filter. So back filter is used for removing the dust with the aid of cylinders made up of closely woven material, cloth laga. Selected material allows the air to pass through them, but not the solid particle. So through this cloth-like material, the bag can allow the air to pass through it, but it will not allow solid particles through passing through it. So solid particles will be prevented and gas will be passing from these bags. So that is the basic principle in the bag filter. So bag filters work on two stages or two steps, we can say. One is filtration step and other one is shaking or vibration state, or we can say filtration period and vibration or shaking period. In filtration period, what happens? In this period, the milled or finely reduced powder is fed into the cloth bag by applying suction on opposite side. So due to application of this suction, the particles are entering into the bag and all of them are stuck in that bag and air simply escapes out. But what's happening? All these solid particles, fine particles are sticking to the bag. And in when second stage, that is in shaking stage, when vacuum is removed, sudden change in the vacuum causes these bags to vibrate. This shaking and vibration will allow the particles to sediment down or fall down from this bag. So these two are the mechanisms: shaking period and filtration period or shaking state and filtration step or state helps in separating the air from this dust particle. See the construction, very important. Bag filters consist of several cotton or wool bags. పేర్లోనే ఉంది cotton or wool bags suspended in a metal casing. See. So these are the bags. The yellow part which I am showing, these are the bags. So this is the bag. This is the bag. Right? So first step, what's happening? See, air is entering into these bags and air is coming out of these bags. Then what is stuck in middle? These dust particles, like this, right? And in second stage, what's happening? See, when initially in first step during filtering period, this is closed. You can see screw clamp is closed. So the connection between the atmosphere and these bags is closed. But during shaking period, the connection is open. You can see the arrow here. సో ఆ ఆరో వల్ల ఏమైతుందంటే ఇక్కడ ఎయిర్ లోపల నుండి బయట నుండి లోపలికి రావడం వల్ల ఇక్కడ షేకింగ్ జరుగుతుంది. సో ఆల్ దీస్ డస్ట్ పార్టికల్స్ ఆర్ collected here. So you can see the hooper is at the bottom. This is the hooper present at the bottom of the filter, receives the feed. An exhaust outlet is present at the top of the metal container. The bell crank lever present on the present for maintaining the normal atmospheric condition. This is the bell crank system. సో బెల్ క్రాంక్ సిస్టమ్ ఎలా ఉంటుందంటే సింప్లీ కీ ఇచ్చినట్టు ఇస్తామండి. లైక్ ఇన్ ఆఫీసెస్ వినో నాట్ ఎలక్ట్రిక్ వన్ బట్ మెకానికల్ బెల్ విల్ బి దేర్. ఇఫ్ ప్రిన్సిపల్ జస్ట్ tap it, it will ring, right? We will simply rotate it and crank it and keep it aside. So after pressing for certain times, it is open. So like that, you will be bell crank opening system will be there. So in working, like just we discussed two steps. Step one is filtration step. Step two is vibration step. Step one filtration step, what's happening? Simply you are applying the vacuum at the top and the connection between the atmosphere and these bags are closed. Because of this vacuum, the air is sucked inside or the feed is sucked inside and feed is simply going, air is simply going outside and all these solid dust particles are blocked or filtered by these bags. Stage one. Stage two, you're opening this bell crank. You can see these arrow marks. You can see air is entering into the device. Here air is existing from the device. So the air local radam valla sudden ga it vibrates. And this vibration will allow in collecting the particles here. This is the working. You can see the bags are shaken so that the adhered fine particles fall into the hooper. So, okay. So uses of chassis, it is used along with the other size separation equipment like cyclone separators. It is used equipment on the top of fluid bed dryers because the dust can be efficiently separated. It is used to clean the air in the room and household vacuum cleaners. If you see in your air conditions, అక్కడ ఇండోర్ యూనిట్ ఓపెన్ చేస్తే ఫిల్టర్స్ ఉంటాయండి. అవి ఈ బ్యాక్ ఫిల్టర్సే. మీ వాక్యూమ్ క్లీనర్ లో కూడా యూ హ్యావ్ ఫిల్టర్స్. Oh, same these back filters only. You can clearly see the back filters, right? I'll show you the video so that you can clearly see how back filters will appear on working mechanism. Then you can finish this class so that you can clearly understand it. So let me stop this. I'll show you the YouTube video. Okay. Yeah. So just last moment, let me show you how back filters are going to work. Yeah, yeah. Yeah. So can you see my screen? Can you see my screen? You can see the screen of back filter. కనిపిస్తుందండి?
Okay.
See. See, you can clearly see, like just I explained, these are the bag filters where inside the bags, air and dust particles are being stored. Right? So this is the step one filtration stage. See what's happening in filtration state. So the connection between the environment is closed. Right?
Okay.
In second stage, when connection opens, it will start vibrating. So reverse mechanism, pulse jet flow clearly the bags at pre-programmed intervals. So it will shake avadam valla అందులో collected and dust particles are collected down. So you know dust particles are falling down. So this is how bag filters works. I hope you understood. Right? You can see it clearly. Can you see the screen? Listen to the voice.
Yes, sir.
See the back filter. Shaking period. Yeah, I'll try to show you the fluid energy mill also. Yeah, see, you can see the sponsored videos of generally industries which show us exactly working of back filters and all. But anyhow, I want to show you the mechanisms so you should remember this all. See, మనం చెప్పుకున్న బ్యాక్ ఫిల్టర్ ఎట్లుంది ఇండస్ట్రీ ఎంత పెద్దగా ఉందో చూడండి టూ బిగ్ రైట్ next I would like to show you fluid energy mill. That's what we already discussed. So let me show the animated fluid energy mill if possible. Yeah, so can you see my screen?